Wave equation. This is practice, and it's also about how to get the maximum number of marks in a GCSE paper. So it's what the examiners are looking for. So any or all of the following points can make up the available marks in a calculation question. So we're specifically going to look at waves and the wave equation, but these are the different things that an examiner can give you marks for. Not necessarily all of them. In every question, there'll be a different amount of marks available in different questions, but these are the things you'll need to include. So a suffix, the number might have times 10 to the power of 6 after it. You need to know what that means. Or a prefix, you might have a capital M before the units, and you need to know what that capital M stands for. And the units need to be in the correct format for the equation. You need to know the equation, and you could get a mark for writing down the equation. It's important to note, if you write down the triangle, that's not an equation, so you don't get marks for that. You then have to substitute the numbers in the correct place. That is quite often a mark on a GCSE paper, and it's probably one of the easiest marks available if you remember to put it in there. There's possibly a mark for rearranging the equation, and then there'd also be one for the numerical answer. And again, finally at the end, the units and significant figures. Basic rule on significant figures is use the same number of significant figures as there is in the question, and you won't go far wrong. So here we have, this is the wave equation. Velocity is in meters per second. Frequency is in hertz. Hertz are waves per second. And the wavelength is in meters. So you've got to check when you get a question that is correct in the question. If not, you may have to change it to make it correct. I would suggest you always use the equation in this form, V equals F lambda, because it's easy to get the substitution mark that way. And don't bother remembering it as the triangle. So here we go. What's the speed of a water wave with a frequency of 0.5 hertz and a wavelength of 3 meters? First of all, no suffix, no prefix. And the units are all correct. Brilliant. So now all I need to do is write the equation down. There we go, I've written the equation down. Now I need to put the correct substitution. That's the substitution in there. And again, it looks fine to me. So there's no rearranging. So all I need to do is make the calculation and then add the units at the end. So 1, 2, 3, 4 possible marks there. Quite often they'll give you the units at the end, so you won't have to do that. And check that you haven't recorded to a significant difference to the question. Here we could have said significant figures, or we could have said decimal places. So we've gone to 1 decimal place there, so 1 decimal place there would be fine. Next then, 2 incorrect answers to the same question. So have a look and see if you can work out what the 2 people have done wrong. And then have a think about how many marks these 2 people who've given these 2 answers is going to get. Hopefully, you've worked out that V equals F lambda is correct. What about the speed? It's 1.5 meters per second, wavelength's 3 meters. Have they put them in the correct place? Yes, they put them in the correct place. So that's okay. Now let's have a look at the next bit. We've got 3 divided by 1.5. Well, that's where they've gone wrong. They've rearranged the equation incorrectly. Now there could have also been a mark at the end for writing the correct units for frequency, which is in hertz. Might be, might not be. Let's have a look at the other person. Well, they've written down the equation incorrectly. So they can't get the mark for the substitution either. but they could possibly get a mark if there is one available for the correct units for frequency. So the two people have made exactly the same error, which is that rearranging error. But look how many marks the first person's got in comparison to the second person. Both students made the same error in rearranging the equation, but one going to gain 60% of the marks, the other only 20%. So there we go. Sorry, 60%, because it could have been out of 5, because rearranging and the numerical answer, they get 1 out of 5 for theirs. The second student decided to go straight for the rearranging at the start and only got this wrong. This led them to only getting the mark for the correct units. So the same mistake, two people, same mistake. One person gets 60% of the marks, the other person just gets 20%. That's why it's important to set things out in this way, because that ensures you pick up the easy marks. So here's the correct answer. What is the frequency of a wave whose speed is 1.5 meters per second and the wavelength is 3 meters? First of all, you write the equation, then you put the numbers in, the substitution, then you rearrange it. The 3's multiplying on here, so the 3 becomes divide over there. Perhaps you could have put a step in the middle where you'd have done 1.5 divided by 3 equals f. So you've kept the f on the same side. Might be easier for some people to do it that way. And then we get 0.5 hertz answer in units. So, prefixes and standard form. Nano times the -9. So this standard form, that's the suffix. It comes after the number. These are prefixes. These will come before the unit. So micro, milli, kilo, mega, and giga. You've probably heard of mega and giga as in talking about memory on computers. Nano -9, micro to the -6, milli 10 to the -3, kilo 10 to the power of 3, mega 10 to the power of 6, and giga 10 to the power of 9. So here I'll leave you with prefixes and standard form exercise. Copy and complete the table. So you need to have the number, the prefix, and then write it in the standard form, which is a suffix. Off you go. If you wish to pause that now, I'm just going to move on to the answers.